So continuing from where we left off, we are saying interest rates on long-term bonds will equal an average of the short-term rates that people expect to occur over the lifetime of the bond. So it's expectation. What do I expect the interest rates next year to be, in the next year, If I have good expectation about the future, then I can just find the average along that period and then bargain for the average year to year. Okay. So buyers of bonds do not prefer, we indicated that. Okay. So buyers, holders of bonds with different maturity. 1 second, let me swap the slide. Okay. So bondholders consider bonds with different maturities to be perfect substitutes. And then we'll take a look at the example that we're looking at. So if you expect, let's assume that the current rate on a 1-year bond is 6%, and you expect the interest rate on a 1-year bond to be 8%. So 1-year bond today is 6, 1-year bond next year is 8%. Then they could have bought a 2-year bond at 7%. Okay. All right. So then expected returns from buying a 2-year, 1-year bond average is 6% plus 8% plus 7%. The interest rate on a 2-year bond, if you're buying a 2-year bond together, the average will be 7% for you to be willing to purchase it. So 7 years, 7%, 7%. I hope this is clear. Let me still try to. Let me reshare a better version of the slide. Okay. All right. So expectation theory. So that is the idea that we just discussed. We can, economists, we like notations. Let me show you the notation version of this simple analysis that we've just gone through. Okay. For an investment of say 1 Ghana cedi, so you're investing 1 Ghana cedi, notation purposes, let's assume today's interest rate on a 1-period bond. So if you're buying 1-period bond, today's interest rate, get a piece of paper and write this also down. So today's interest rate on a 1-period bond, if you're buying a 1-period bond, that is IT. Okay. That's IT. Today's interest on a 1-period bond. Interest rate on a 1-period bond expected for next period. What is the interest rate on a 1-period bond that you expect for next period? So that will be IT plus 1. Okay. What happens if you are doing today's interest on if you are buying a 2-year bond together instead of doing it 1 year, then the interest rate you will get will be I2T. What we are saying, even before we go to the derivation, what we are saying, you can also write it somewhere, that I2T equals IT plus IT plus 1 divided by, it's an average, 2. Okay, it means this, if you are buying a 2-year bond, today's interest on the 2-period bond will be the average of the two. So the interest rate on a 1 period and then the expectation that you have, the IT plus 1 expected divided by 2. Okay, so let's see how we derive it. We come to this. Okay. Smith-Sheen theory over the 2 period for investing 1 CD or 1 USD in the 2-period bond and holding it for 2 periods. Okay. So if I was buying a 2-period bond, what would be my returns? If I was buying a 2-period bond, the first period I'm going to get I2T, okay, the 7%. Okay. The second period I also get I2T, another 7%, minus my initial investment. If you multiply through this, you're going to get 1 times 1, which will give you 1. 1 times I2T will give you I2T. And then you have I2T times 1 will give you another I2T. That will give you 2 I2T. Okay. Then you are going to get I2T times I2T. That will give you I2T squared, okay, minus 1. Just do this exercise. Just multiply this bracket by that bracket. It should give you something like this. Okay. We are saying that this is 1 initial investment. So that 1 cancels that. You are going to get 2 I2T plus the I2T squared, raised to the power 2. Let's say the I2T, which is the average, is 7%. 7% is 0.07. You do 0.07 raised to the power 2, it's going to be a very, very small number, 0.00 something. Okay. So since I2T raised to the power 2 is very small, the expected return for holding a 2-period bond for 2 periods, if you're buying a 2-period bond, holding for 2 periods, is 2I2T. I will give you this right somewhere. That is 2I2T. If you are buying, you are getting 7% times 2, because it's 2 periods. So 7% times 2. Okay. How about, let me recap this. Okay. The expected return over the 2 periods from investing 1 CD or $1 in the 2-period bond and holding it for the 2 periods. If you do that, the first period, you are getting the average interest rate that you bargained for. Yeah, even though you are holding it for 2 years, you have bargained that on average, this is what you are getting. So you are getting the first case, 7% I2T. Okay. The second year, you also get the same 7% I2T minus the initial investment you put in. 1 cancels 1, and then you are left with 2 I2T plus the raised to the power 2. And I said the rates are very small, so the I2T can be 6%, which is 0.006. Raise that to the power 2, that will be very small. So the expected returns over a 2 period for investing 1 and holding it for the 2 period is 2 I2T. Okay. If we are doing 2 1-period bonds, so 2 1-period bonds, and they are bought also with 1 investment, it means that the first period you are buying at IT. Okay. You are buying at IT. Remember, go back. It's that IT is today's interest rate on a 1-period bond. So the current interest rate on a 1-period bond is 6%. You expect the interest rate on a 1-period bond to be 8% next year. So IT plus 1 expected interest rate on the 1 period bond expected for next year to be 8%. Then you are going to get this. So here you are buying 1 period, 1 period. So the first period you are getting IT. The second period you are getting IT plus 1 expected minus the initial investment. The same thing that we did, multiply the two brackets. 1 times 1 gives you 1. 1 times IT plus 1 expected will give you IT plus 1 expected. IT plus 1 will give you IT. And then the last bit you have IT times IT plus 1 expected. That gives you this relationship. Minus 1. Okay. 1 cancels 1. You're left with IT plus 1 expected plus the product of it. IT times IT plus 1 expected. In the previous example we had, we said IT was 6%. So that is 0.06 times IT plus 1 expected was 0.8%, so 0.08. If you multiply that, that is also a very small number. So this interaction here is also extremely small. That will mean that the expected returns from buying a 1 period bond twice, so you buy 1 period, next year you buy another 1 period, will be the expected return will be the first period you will get IT, and the second period you will get IT plus 1 expected. However, if you had bought a 2 period bond at the same time, you are going to get 2 I2T. So doing it one by one. If you have done it together, 2 period bond, you are going to get 2 I2T. So in principle, 2 I2T, you are saying the returns on the short term on the average, the short term equals to the long term. Okay. So the long term returns of 2 I2T equals the returns on the short period, which is equal. So you write 2I2T equals IT plus 1 expected. Okay. That's what we are saying. So 2I2T equals IT plus 1 expected. And therefore IT equals the average that we just saw. So if you are buying it one by one at a time, if you find the average is equals to, if you are buying it together, the average rate you get. So the 2 period rate must equal the average of the 2 1 period rates. For bonds with longer maturity, then you have to form expectation also about. Okay, so this is what we have. If you are buying a longer period, it's IT plus 1 expected, and IT plus 2, or the up to IT plus N, or the number of periods that you are buying divided by the number of periods N. Okay. So if you are buying from expectation next year, the year after, okay. If you are saying the average over the lifetime of that bond, if it's 10 years, over the lifetime of that bond, the average should be equal to, if you were buying together 10 years at the same time. So the average rate will be INT. The end period interest rate equals the average, so the 10-year interest rate on a 10-year bond, the interest rate should equal the average of the 1 period interest rate expected to occur over the 10 years of the bond. Okay. So let me retake that. The 10 period interest rate, okay, equals the average. So if I'm buying a 10-year bond and I'm saying, okay, I'm going for a 10-year bond, the rate I will get should equal the average of, if I was doing it one bit by bit over the 10 years of the bond. All right, let me try to summarize some of the things. The expectation theory therefore explains why the term structure of interest rate changes at different times. Importantly, why interest rates on bonds with different maturities move together. So expectation theory is saying that if you have a firm expectation about the future, then the interest rate on short-term, interest rates on bonds with different maturities will move together, because the average of the one will be equal to the long term. Okay. If that is the case, why yield curves tend to slope upwards when short-term rates are low and slope down when short-term rates are high? Because you form expectation. So if you are forming expectation, then you expect that if today I'm taking it the 1 year bond at 6%, then you expect next year to be slightly higher, 8%. The next year will be slightly higher. So the yield curve should be upward sloping. Okay. So that covers the first two facts that we had. So if you go back, the first two facts, expected to explain the first two facts. Interest rates on bonds of different maturities, they move together. Even 10-year, 1 year, they all move together. When short-term rates are low, your curves are more likely to have an upward slope. Okay. So it explains the two facts. The expectation theory explains the two facts. So fact one and fact two cannot explain why yield curves usually slope upwards, a general trend. Okay. The second theory is the segmented market theory. And the segmented market theory is saying that bonds of different maturities are not substitutes. Remember, we said that in expectation, because you're forming expectation, it doesn't matter whether you're buying a 1 period bond 10 times or you're buying a 1-10 period bond. Okay. So here we are saying bonds of different maturities are not substitutes. Why? Because under segmented market theory, you're saying that interest rates for each bond with a different maturity is determined by the demand for and supply of the bond. In simple terms, it means that the market is segmented. There is the demand for short-term bonds and there are demand for long-term bonds. So the market is segmented. There are people who like short-term bonds. They prefer short-term, 5 year, 2 years, 1 year. There are people who like 20-year bonds. So it depends on the demand and supply conditions of the bond. So on a segmented market, the market is segmented. Investors have preference for bonds of one maturity over the other. So they are not perfect substitutes. If investors generally prefer bonds with shorter maturity, so think of the analysis we did with the demand and supply curve. If investors prefer bonds with shorter maturity, okay, then that have less interest rate risk, then this explains why your curves will slope upward. Okay. Let me retake that. If investors generally prefer bonds with shorter maturities, say we all prefer 2 year, 5 year bonds, shorter maturity, then demand for the bond will increase. If demand increases, because we are all risk averse, then you don't have to pay you a higher interest, because there's a lot of people who are demanding short-term bonds. So the interest rate will be very low. Then they are on the flip side, if people are not demanding long-term bonds, if you want to incentivize people to demand long-term bonds, then you have to give them a higher interest rate, because the demand has dropped. Okay. People don't want it. So if you want them to buy, for me to buy a 20-year bond or 30-year bond, you probably have to give me a higher rate. Year to year into the 30 years, you have to give me a higher average rate. Okay. All right. So we are saying the segmented market theory explains the third fact, the fact that the demand condition and supply conditions are different for the two bonds. And for that reason, it explains why the yield curve is sloping upward, because because in the first case, in the short-term bonds will have a lower interest rate than a long-term. Long-term bond will have a higher interest rate. Why? Because people are not demanding more long-term bonds. It can also have an inverted shape. Okay? If people are demanding more long-term bonds, like the Japanese case, people like investment, they want long-term bonds. If demand for long-term bonds increases, the interest on long-term bonds will fall, while short-term bonds will be higher. Then you have the inverted case. All right, let me touch on the last one, liquidity premium, or the preferred habitat theories, and the preferred habitat theories. Here we are seeing the interest rate, and remember we said that theory combines the two to explain all the three. Okay. So the liquidity premium says that the interest rate on long-term bonds will equal an average of short-term interest rates expected to occur over the lifetime of the long-term bond. That is expectation theory. But then they add plus a liquidity premium that corresponds to supply and demand conditions for that bond. Okay. So very smart. Added the two theories together. So the second component is saying it's not just the expectation theory. So I form expectation about the future, and then I bargain for a rate here. But you have to also compensate me with the fact that I am waiting for a longer period. You have to compensate me for that. But the compensation depends on the supply and demand conditions for these long-term bonds. All right. So bonds of different maturities in an liquidity premium, they are partial substitutes. And expectation theory, they are perfect substitutes. And so under segmental market theory, they are not substitutes at all. And here we are saying they are partial substitutes. They are partial substitutes. Liquidity premium theory can be represented as this. The first component is just expectation theory. IT plus IT plus 1, expected IT plus 2, expected up to the end, divided by N, plus a liquidity premium. So we add a liquidity premium, L. And the liquidity premium is the liquidity premium for the end period of bond at time T. So if I'm waiting for 10 years, the liquidity premium you add will be different from if I'm waiting for 5 years. So we are saying liquidity premium is positive and rises with the term to maturity. So I get a higher liquidity premium if I'm waiting for 30 years. So if somebody is waiting for buying a 20-year bond, fine, I form expectation, but you have to also compensate me for that length of time. All right, so investors have a preference for bonds of one maturity over another. They will be willing to buy bonds of different maturities if they earn a somewhat higher expectation. So if I'm buying a bond of different maturities, I will only do that if I earn some expected returns, if you give me a liquidity premium. So I'm going to lock up my capital for that period. So you have to compensate. So investors are likely to prefer short-term bonds over long-term bonds. So this is the yield curve that we have here. Expectation theory will be the flat line. If you do a 5-year bond, you are getting 6%. If you do a 30-year bond, you are getting an average, also getting an average year into the 30 years of 6%. However, if you are doing, if you add a liquidity premium, the liquidity premium is that curve here that it widens as the length to maturity increases. So you need to compensate me. I'll get a 6%, but you have to add plus my liquidity premium, how long I'm waiting. And people prefer to be in this habitat. If I'm waiting, I should be in this habitat. I should not be on the expectation theory line. All right, interest rates on different maturities move together over the over time explained by the first term in the equation. Yield curves tend to slope upward when short-term rates are low, tend to be invented, explained by the liquidity premium. Yield curves typically slope upward, explained by a larger liquidity premium as the time to maturity increases. So if I'm waiting for a longer period, then it should be, that's why it's always sloping upward. Or because if I'm waiting for 30 years, it should be upward. Long-term rates should be higher than short-term rates. So these are examples of yield curves. This is upward sloping. So here the long-term rates are higher than short-term rates. Okay. In this case, they are the same. Here, the short-term rate is higher than the long-term rate. All right, so we'll end on this slide. So just keep in mind the expectation theory, segmented market theory, and the liquidity premium and preferred habitat theory. You can go over the slide or the video just to understand it better. All right. Thank you for listening to this session. See you next time.